Hello everyone, welcome to A1 Tutor Live class and welcome to the mathematics class. Our last class we discussed a new topic which was geometric progression, and we were able to make justice to the concept of geometric progression using a real life example. We're able to use the illustration of a student who happens to be saving a certain amount of money on daily basis. Let's say the name of the student is Kunle. We said Kunle is a student that decided to save money in dollars, right? And on day one, he saved 100 US dollars. And day two, he decided to save double of what he saved in the first day. So if he saved $100 in the first day, the second day he doubled it and he saved $200. Now on day three, he decided again to double the money he saved on day two for that of three. So on day three, he saved $400. Now looking at this, we have a progressive way of the saving process, which implies that he is actually following the principle of doubling. The principle of doubling, that is trying to double any amount he saved at the initial day. So now, if on day one he has 100 US dollars, on day two he has 200 US dollars, on day three he has 400 US dollars, we can see that something is common in the way he's saving, which is double, double, okay? If I'm going to take day two savings divided by day one, that would be 200 US dollars divided by 100 US dollars. And what you're going to get is 2. If I'm going to consider day three savings over day two savings, we're going to have 400 US dollars over 200 US dollars. When you divide this, you have what? 2. So what do you notice? That the ratio of the savings of the initial day over the present day is 2. The ratio means when you are taking the division of the day before and the day after it, you are getting the answer to be 2, which implies that he has been saving using the process of multiplying any money he has saved initially by 2, by 2, by 2. So that is what we call geometric progression, geometric progression, geometric progression. And we're able to also talk about the formula in geometric progression. We have 3 formula. The first one is the nth term of a GP, the nth term of a GP. We talked about the nth term of a GP and also the sum of a GP, the sum of a GP. And lastly, we discussed about the sum to infinity, the sum to infinity, the sum to infinity. So these are the 3 segments of the topic geometric distribution that we did in the last class. So if perhaps you are not available or you're not chance to join the class as live class, you can do well to visit the YouTube channel and watch the part 1 of geometric progression. It's already uploaded to the YouTube channel. Search for A1 Tutor, A1 Tutor, and there you are going to have the list of all our videos. Search for geometric progression part 1 and watch the video and have a vast knowledge on geometric progression. I think to make it very easier for you to always get updates and notifications of our video, I will say you should subscribe to the YouTube channel. Do well to subscribe, okay? Just click on the subscribe button, then it's going to be very easy to get updates, to get notifications of our videos as they are being uploaded. All right. For all subjects, we'll be uploading every day. So do well to just subscribe and you'll be having notifications as those videos are being uploaded. Thank you for that. Now, today we are going to focus on solving questions, that is applications of geometric progression. But we are going to be basically using UTME questions. We are going to be using UTME questions. So we'll be more familiarized with how UTME asks questions on this topic, geometric progression. So today is basically to solve questions from the UTME under the topic geometric progression. All right. Okay, let's dive into the questions. Let's start with the first question. If you are with me and you can hear me, please kindly signify while we are trying to make the board clean and start with the first question. Thumbs up if you can hear me. Okay, thank you, Adeyemi Peter. Okay, let's proceed. Permit me to wipe the board. This was the recap of what we did in the last class. And today, like I said, we'll be solving questions on the topic geometric progression. Geometric progression. Okay, so the first question, we're going to be taking the first question. The first question in geometric progression. And as well, we are going to be identifying the years where the questions are coming from, so we can be sure that we are working with the UTME question. That will build your confidence that you can actually handle UTME questions. All right, so the first question we're going to be taking is this question from 2021 UTME question. 2021. This is question number 1. UTME question 2021. Now, when you solve past questions like UTME questions, you have this confidence within you that actually you can solve all these questions when you get to the exam hall. And that is why we decided to make use of UTME questions so we can get familiar with how the questions are being structured under each topic. So now let's solve this question together. Like I will always say, try to decode the question. Try to decode the question. The question has been encoded with some particular information. So it is for you to decode the question before you proceed to solve. And in the process of decoding the question, you are trying to comprehend what you are asked to do. You are trying to comprehend what you're asked to do. The question says that second term of a geometric series. The second term of a geometric series is 4. Is 4, the second term. T1 represents first term. That is, T2 will be what? Second term. T represents term, and the number 2 here represents the second term. So the second term of a geometric series is 4. So T2, which is the second term, is given to be 4. All right? The second term is given to be 4. Now, I've done that interpretation. The second term is 4. Now, while the fourth term, if the second term is T2, the fourth term is T4 equals to what? The fourth term equals to 16. The fourth term equals to 16 from the question. They said the second term is 4 and the fourth time is 16. The fourth time is 16. The question says, find the sum of the first 5. Underline the word sum of the first 5 terms. Find the sum of the first 5 terms. That is, we are asked to find x5. X5 means the sum of the first 5 terms. X for sum. So we have x to be the sum of the first 5 terms. And generally, the formula for sum we have two of it, like we discussed in the previous video. We have xn equals to a into the brackets n minus 1 close brackets r minus 1. We use this formula when your r is greater than 1. Now, we have the second one to be xn is equals to a, open brackets, 1 minus r raised to power n, close the brackets, 1 minus r. We use this formula when your r is less than 1. And what is the r we are talking about? That is, we are talking about the common ratio. R is your what? Your common ratio. And in this information, you don't have r. That means you need to source for the value of r before you can solve for the sum of the first 5 times. Because the formula needs r. But in your information, you are not given r. The formula needs a. In your information, you are not given a. So I need to get a, I need to get r before I can solve for this x5. Okay, I believe you are getting me. Let's proceed. Now, if T2 equals to 4, the general formula for the nth term of a GP is Tn equals to ARn minus 1, where n represents the numbers of time, number of time. All right. Now, what is going to be n here? If this is 2, and we said this represents the numbers of time, what will be the value of n? When T2 equals to 4, what will be the value of n? I need your response in the chat box. If T2 equals to Tn, by comparison, 2 is also equals to what? N. That means in this expression, my n is what? 2. My n is what? 2. So I'm going to have T2 is equals to, using this formula, is equals to AR. N is what? N is 2 minus 1, which is going to give us AR raised to power what? Raised to power 1. Raised to the power of what? 1. Now, what about when we have T4? What is the value of n when we have T4? Can you give me the response in the chat box or in the comment section? For those following us on YouTube, what is the value of n when we have T4 equals to 16? T4 equals to Tn. What will be the value of n? By comparison, like what we did for the first one. What will be the value of n? I need your response in the chat box. And for our YouTube followers, I need your response in the comment section. What will be the value of n for this expression? If you circle 4 and you compare it to the other side here, your n is going to be what? 4. So that means T4 will be equals to the same formula again. AR 4 minus 1 equals to AR raised to power 3. Now, this, we have given you the answer in the question that it will all be equated to 4. So I can say this is equals to 4, and this is equated to 16. That is, this is equals to what? 16. So let's call this equation 1 and this equation 2. Equation 1, equation 2. How do we get the value of A and R? To do that, we are going to say divide equation 2 by 1. Divide equation 2 by 1. That is, we are going to have equation 2, which is AR raised to power 3, divided by equation 1, which is what? AR equals to the constant part. Equation 2, the constant part is that number after the equal sign, which is what? 16. We have 16. And for equation 1, we have what? 4. And that is what? 4. By simplification, we have A cancel A, and R here cancel 1 out of the R here. We have 2 left. Dividing 16 by 4, that will give us what? 4. That is, we're going to have A has cancelled A out. All we have is R squared is equals to 16 divided by 4, which is 4. And to get the exact value of R, we're going to take square root of both sides because we have a square. Square root both sides. Square root both sides. That is the square root of R squared equals to the square root of 4. The square root of R squared equals to the square root of 4. Let's have the continuation here. The square root of 4, that will give us 2. The square root of 4 will be equals to 2. So we're going to continue at this portion of the board. We have R now, because the square will cancel the square root. We have R equals to the square root of 4, which is what? 2. The square root of 4, which is 2. So the square root of 4 is 2. That is the common ratio, which is R, is equals to 2. Now, we are getting to the final answer already. But we have not gotten A. We've gotten R. And I said this is what we want to solve, actually, this formula. And you need letter A and letter R. You've gotten letter R, but you've not gotten letter A. How do you get A? You have to substitute R equals to 2 either in equation 1 or equation 2. You substitute R equals to 2 in either equation 1 or equation 2. For easy solving, I'm going to substitute in equation 1. And what is equation 1? Equation 1 is AR equals to 4. Substitution means you are going to replace R by 2. R by 2, and that has to be in a bracket. It has to be in a bracket. So we have A into the bracket 2 equals to 4. That is 2 times A is 2A equals to 4. Dividing both sides by 2, A will be equals to 4 over 2. A is equals to 2. That is 4 divided by 2. 4 divided by 2 is going to give us 2. So the value of A is 2 and the value of R is 2. The value of R is 2 and the value of A also is 2. Now we've gotten R to be 2 and A to be 2. Now we can solve the question. The question is find the sum of the first 5 terms. Find the sum of the first 5 terms. Find the sum of the first 5 times. Now we are going to do that now. The question I'm going to ask is that we have formula 1 and formula 2. If your R equals to 2, which of this formula are you going to use? Is it 1 or 2? Take note, you are going to put 2 here and put 2 here. If 2 is greater than 1, you'll be using the first one. But here, it is R is less than 1 and 2 is less than 1 is not correct. So we can't go for this formula. We'll be going for this formula that says R is greater than 1. So if I may ask, which of the formula are we going to use? Is it the number 1 formula or the number 2 formula? Please kindly drop your response in the chat box. And for our YouTube followers, drop your response in the comment section. Are we to use number 1 formula or number 2 formula? After we've gotten R to be equals to 2, and we said there is a condition to use each of this formula. When R is greater than 1, you use formula 1. When R is less than 2, when R is less than 1, you use formula 2. So which of the formula are we going to use? Your response in the chat box. Which formula are we going to use? We are going to be using formula 1 because 2 is greater than 1. We'll be using this formula to get the sum because 2 is greater than 1. So I'm going to permit you to take a screenshot before we wipe the board so that we can move on to the continuation of the solving. Take a snapshot of this so that we can continue. And if you have done that, please thumbs up so I'll be aware and I will be able to proceed. Take a snapshot or take a screenshot of the screen so I can wipe the board, and we are going to proceed to the conclusion part of the solution. Please, if you have done that, thumbs up, thumbs up, thumbs up, so that we can proceed. If you have done that, if you have taken screenshots of this, please notify me by a thumbs up. I'm expecting that. I'm still waiting. Are we good to go? If yes, thumbs up. Are we good to go? Can I wipe the board now? Okay, thanks for that. Now let's proceed. Thank you. Thank you for your response. Thank you for your response, Abiodu and Peter. Let's proceed. Now we've gotten R to be equals to 2 and R to be equals to A. So I'm going to wipe the board. Then we're going to continue with the solving. All right, we're going to continue with the solving. A was equals to 2 and R was equals to 2. I want to get x5, which is question mark. Now, because R is greater than 1, that is 2 is greater than 1, I'm going to use xn equals to A, open bracket, Rn minus 1, close the brackets, R minus 1, where R is 2, where A is 2, and xn is unknown, and n is equals to 5. N is equals to 5, which is this 5 that we have here. The value of n is equals to 5. So let's go ahead to substitute xn, that is x5, equals to 2 in brackets, 2 raised to the power 5 minus 1, close the bracket, all over 2 minus 1. That is x5 equals to 2 in bracket, 2 raised to the power 5 is 2 times 2 times 2 times 2 times 2. That is in 5 places. We are going to get 32 minus 1 all over, subtracting 1 from 2 at the denominator, subtracting 1 from 2. The answer is 1. We have x5 equals to 2 in brackets, subtract 1 from 32. The answer will be 31 over 1, which is the same thing as 2 multiplied by 31. 2 multiplied by 31. X5 equals to 62. X5 equals to 62. And if you are going to check the option, you will see that the option is option C. The correct option for that question is going to be option C. Let's have the options. So the correct option for this question is going to be option C. So that UTME question, the answer will be C. The answer will be C. I believe that is clear to us. If yes, please thumbs up. And for our YouTube followers, if this particular question is clear to you, the explanation, please drop a comment in the comment section. Drop a comment in the comment section. And if you have a question you want to ask, as the YouTube followers, you can drop your question in the comment section. We will definitely attend to your question concerning this question that we've just solved. If this is clear to us, please thumbs up. We are moving on to the next question. We still have 1 more or 3 questions to solve on this topic. If this explanation is clear to us, please thumbs up, so that we'll move to the next question. The next question. Okay, UTME question. 2009. UTME question 2009. Permit me to wipe the board. 2009. So we have this question to solve, UTME question 2009. Okay, so this is the question we want to solve. UTME question 2009. 2009. Find the infinity, find to infinity the sum of the sequence. The sequence 1, comma, 9 over 10, comma, 9 over 10 all raised to the power of 2, comma, 9 over 10 all raised to the power of 3, and we have comma, dot, dot, dot. So we are asked to find the sum to infinity, the sum to infinity of this sequence, the sum to infinity of this sequence. Let's solve that together. First, you need to identify that this is the first term, the second term, the third term, and the fourth term. So we are given 4 terms. Now, how do we solve this? First, you need to know what is the formula of the sum to infinity. And that formula will lead you to get what you need to get from this given information. Sum to infinity, represented by this symbol, is equals to A over 1 minus R. So this is the formula for sum to infinity. Sum to infinity. So in this question, if I want to solve this question, I need to get A, letter A, and I also need to get letter R from the given question. So how will I do that? Take note that letter A is also equals to T1. So that means letter A also represents the first term in the what? In a sequence. The first term in a sequence is T1 and is also referred to as letter A. And how is that possible? Using mathematics, of course, the first letter in using English, the first letter in English is A. So that is why they decided to make use of A, representing the first term of a sequence. The first term of a sequence is A, meaning first term. All right. So we have A to be T1. That is, A will now be equals to 1. This is A. This is representing A. All right. Now, how do we get R? R equals to, because it is GP and it is called common ratio. We call it common ratio. And common ratio is obtained by this formula, T2 over T1 or T3 over T2 or T4 over T3, and so on and so forth. All of these will give you the same answer, the same answer. Okay? All of this will give you the same answer. Let's make use of the first one, T2 over T1. T2 over T1. R equals to T2 is this. This is T2, which is 9 over 10. Then over means division, divided by T1. T1 is what? Is 1, which is the same thing as 9 over 10. Change the division to multiplication. We have times, which is 1 over 1. And when you simplify this, it's going to give us 9 over 10. So the common ratio for this sequence is 9 over 10. the common ratio is 9/10. Okay, so if I've gotten the common ratio R to be 9/10 and A to be 1, I can solve for the infinity by writing A over 1 minus R, which is equivalent to 1 over A is 1. So I replace letter A by 1, 1 minus, then R is what? 9/10, 9/10. To simplify this, I will have 1. This line of division means over, which is also divided. So I will say 1 divided by, open the bracket, the denominator, 1 minus 9/10. Of course, I have to deal with the bracket first. Following the rule of board mice, I have 1 divided by, inside the brackets, I'll find the LCM to be 10, LCM of 1 and 10, because this 1 can be expressed as 1/1. So the LCM of 1 and 10 is 10. And by multiplication, by simplification of LCM, if I have 10 divided by 1, I will have 10 multiplied by the numerator. That is going to give me 10 minus 10 divided by 10, that is 1. 10 divided by 10, that is 1. 1 multiplied by the numerator, which is 9. We have 9. Close the brackets. That will give us 1 divided by, open the brackets, or no need of using the bracket anymore. Take away 9 from 10. Subtracting 9 from 10, the answer is 1/10. And this will give us 1 multiply. When you change your division sign to multiplication, there's going to be a reciprocation. So 1/10 will change to 10/1 because I've changed to multiplication. So I'll be having 10/1, which is equals to 10/1, and the final answer is 10. So the sum to infinity of this sequence is 10. And let's check the option. The answer is option A. The correct answer is option A. The correct answer is option A. If this is clear to us, please kindly signify. We are moving on to the next question. Thumbs up if it is clear to you. We are moving on to the next question. And to our followers on YouTube, please try as much as possible to subscribe on the YouTube channel so you can have notifications of our videos. Try to subscribe on the YouTube channel. Do not just subscribe. Please do well to like, comment, and share. We always want to have your review concerning the videos we upload. We always want to have your questions in the comment section. So feel free to express yourself in the comment section. Thank you. So we are going to take the next question. And I want you to take a snapshot of this. If you are following online for the live session, take a snapshot of this while I'm going to wipe the board to bring in the next question. If you have done that, please thumbs up. If you have taken notes, you have taken a snapshot or a screenshot of this, please kindly signify so we can move on to the next question. Kindly signify so we can move on to the next question. Okay, thanks for your response. Let's pick up the next question now. The next question we are going to be solving, still on UTME questions. Still on UTME questions. Okay, so we are going to solve another question. UTME 2018. UTME 2018. So we'll solve this question. UTME 2018. We are asked to solve this question. find the 11th term of a progression 4, 8, 16, dot, dot, dot. We are asked to find the 11th term. The 11th term. We've used the formula for sum of a GP. We use the formula for sum to infinity. Now we want to look at the formula for the nth term of a GP. The nth term of a GP. So in this expression given to us, this is T1, T2, and T3, which implies that A equals to T1, which is equals to 4. A equals to T1, which is equals to 4. What is now the value of R? Common ratio. That is T2 over T1, T2 over T1. That will be equals to 8 over 4, which is equals to 2. So the common ratio for this sequence is 2. The common ratio for this sequence is 2. If the common ratio is 2, then let's go ahead to solve the question now. The nth term of a GP is what we are asked to find. The nth term of a GP, and the term we are looking for is the 11th term. So we are looking for the 11th term. The general formula is Tn equals to ARn minus 1. So in this question, n is given to be the 11th term. So n equals to 11. A equals to the first term, which is what? 4. A equals to the first term, which is what? 4. A equals to 4. Then we need to get R. R have been solved here to be 2. So R equals to 2. Substitute all this inside the formula. We have T11 equals to AR n minus 1. So we need to substitute what is A. A is 4 multiplied by R. R is 2 raised to the power of 11 minus 1. C11, which is the 11th term, equals to 4 times 2 raised to power. If you multiply, if you subtract 1 from 11, you have 10. Now, looking at the options you have here, you need to ensure your answer is in alignment with the option. The first one says 2 raised to power 13. The next one says 2 raised to power 12. The next one says 2 raised to power 11. And the last one says 2 raised to power 16. So what we have here, if you are going to multiply it out with your calculator or probably multiply it out normally, you will not be getting what you are having in the options. Your answer have to be in the indexed form. That is what the question is requesting, index form. And to do that, I can express 4 to be 2 raised to power 2 times 2 raised to power 10. Using the law of indices, that is 2 raised to power 2 plus 10, which is 2 raised to power 12, which is 2 raised to power 12. So in index form, the answer is 2 raised to power 12, and that is option B. That will be option B. So option B will be the correct answer for this question. 2 raised to power 12. That will be the correct answer for this question. That will be the correct answer for this question. So the 11th term of this question, the 11th term of the sequence given to us is 2 raised to the power of 12. 2 raised to the power of 12 is the answer. I believe this is clear to you. Please do not forget to always drop your question in the comments section. Do well to always drop your question in the comments section. I have few questions for us which I want our followers on YouTube to solve and give us the response in the comment section. As you are watching the video on YouTube, those questions are for you. Solve them and drop your response in the comment section. You can actually give a breakdown of how you solved it, and let your answer come in. We would like to have that response in the comment section. So I'm going to drop those questions for us here so we can also have access to it. Permit me to wipe the board. I believe this example that we just solved is clear to us. So let's have the questions that we'll all be solving, and that we'll be dropping our response in the comment section on our YouTube page. We'll be waiting for that on our YouTube page. Okay, so let's have the questions now. Okay, this will be the first question that our audience will be solving, and share with us the answer in the comment section. And share with us the answer in the comment section. So this is the first question. Let's have the second question. The second question to solve. All right, so we have the second question also. We want you all to solve it and drop your response in the comment section. Okay, so we have the last one to add to it. The last question will be this. So we have two questions to solve. And the last question, this is question number 1. You are going to solve that and give us your response in the comment section on the YouTube page. Number 2 and number 3. Number 3 question is, when are we to use, which formula are we going to use? Which formula will be used when r is less than 1? When r is less than 1, when solving for sum of a GP, So the option to this is option A. Xn is equals to A open bracket Rn minus 1 all over R minus 1. Option B, Xn equals to A open bracket 1 minus R raised to power n all over 1 minus R. So I have two options for question 3. So you have to tell me whether A or B in the comment section. So we have 3 questions for us that we are going to solve and drop our response in the comment section of the YouTube page. Search for A1 Tutor when you watch the video, solve these questions and drop your answers in the comment section. This is the first question, the second question, and this is the third question. So we have 3 questions, and your answers will be within these options that we have in those questions. But do well to give details of how you got your answer in the comment section. Do not forget to subscribe to our YouTube channel, and also do well to comment and share. So today we have been able to take some questions in UTME that has to do with GP, that is geometric progression. We've done the first part, which is geometric progression part 1. It's already on YouTube, and you can do well to watch and understand the concept. The concept was very funny, but it was very impactful. we made it funny for us to understand. There's the concept of geometric progression was explained in the first part of the video. That's geometric progression part one. Do well to watch on YouTube and have a vast knowledge. Do not forget also to solve these three questions and drop your response in the comment section. Thank you. Thank you for your time. And thank you for always following us on our YouTube page. We really appreciate. Thank you for following us online today. Thank you for your time, for joining the live class. In the few time, we are going to have another class. That's the few minutes time. Stay online and stay connected to join the physics class. And today we are going to consider a very interesting topic. Ensure you do not miss any part of this live class. Do well to invite your friends. See you in few minutes time.